Hello, everyone. My name is Dr. Rebet Jones with Capital Technology University. I'm here to present Harnessing the Power of the GPT Model to Generate Adversary Examples. Adversary machine learning focuses on exploiting vulnerability in the ML model, which we call ML machine learning models. In a content or context-based scenario, adversary example can be used to misclassify sentiment or topic. Impact of adversary example in the NLP, what we call a natural language processing. Adversary examples in natural learning process NLP can lead to incorrect prediction or misclassification of sentiment or topic. These examples are carefully crafted input designed to deceive the MLP model and produce erroneous results. So the significance of robust NLP models. Developing robust NLP models is crucial to ensure accurate predictions and reliable results. Robust models should be resistant in adversary attacks and capable of handling various input effectively. So, challenge in developing the robust NLP model. This is the challenges of it. Adversary attacks continuously involve, making it challenging to stay ahead of sophisticated technique. Ensuring robustness required extensive research and testing to identify and address vulnerability in NLP models. Okay, so two different ideas of adversary example in NLP. These results generated using text attack or the LSTM. What they call it LSTM is long short-term memory network on a Rotten Tomato movie review sentiment classification dataset. These are real adversary examples generated using a deep word bug and a text fueler attacks. To generate them yourself after installing the text attack, run text attack model LSTM numeral example 1 receipt num example offset 19 where receipt is deep word bugging or a text fuller. Okay, approaches for generating adversarial examples in the text. So gradient-based method and evolutionary algorithm are commonly used techniques for adversarial machine learning. These methods aim to exploit vulnerability in machine learning models, but often come with computational costs and a need of model access. Gradient-based method and evolutionary algorithm can be computationally expensive, requiring significant computational resource and time to generate the adversarial examples. Additionally, these pros typically rely on access to target model architect and parameters, which may not be always be readily available or feasible. Our pros involve leveraging the GPT language model to address the challenge associated with the gradient-based method and evolutionary algorithm. So, the GPT is powerful pre-trained language model developed by OpenAI known as ability to generate high quality contextually relevant text. GPT provides a rich set of language generation capability that can be utilized for various tasks, including adversarial machine language learning. By leveraging GPT-2, we can explore alternative methods to generate adversarial example without the need for extensive model access or computationally expensive computation. Unique contribution to our study. GPT-2, a powerful language model, demonstrates the ability to generate high-quality adversarial examples efficiently. These adversarial examples can be particularly effective in the content of sentiment analysis. GPT-2 efficiency is generating adversarial example allow for quicker experimentation and exploration of different attack strategy. The high quality of the generated adversarial example ensure that the effectiveness in impacting sentiment analysis tools. Adversarial examples generated by GPT-2 have shown promising results in sentiment analyst benchmark datasets. These examples successfully manipulate the settlement classification of text, leading to misclassification or incorrect sentiment prediction. So, reduction in state-of-art model accuracy. So the application of GPT-generated adversarial example has resulted in a significant reduction in accuracy of state-of-art sentiment analysis tools. That demonstrates the potential vulnerability of sentiment analysis tool by GPT-2 based on adversarial attacks. Okay. So right here on this chart, you'll see the generating adversarial example in the text domain, a review. So growing interest in generating adversarial text, all right, and review of relevant work, comparison with our approach. So the adversarial example generated by GNTL is a BERT-based sentiment classifier, okay? So swapping out perfect with the sentiment spotless completely changes the model prediction. Now, even though the underlying meaning of the text has changed, okay? So, adversarial machine, this is our approach. So, the adversarial machine learning technique employed various strategies to generate the adversarial example. Three notable strategies include text filler, that's the sentiment replacement of deep word bug, genetic algorithm, and partial token replacement using contextual embedding. So now, the text filler was a sentiment replacement strategy. Text filler is an adversarial attack approach that focuses on replacing words in text with sentiment and deceive the NLP model. By strategically selecting sentiment, text filler aims to alter the meaning or classification text while maintaining its overall coherence. Deep word bug, which is a genetic algorithm, deep word bug adopts a genetic algorithm based on approach to generate adversarial examples. The algorithm iteratively evolved to input text by purge-bugging words, assessing their impact on model output, and selecting the most effective changes to optimize the adversarial attacks. So next you have the partial token replacement, the contextual embeddings. Partial token replacement is an approach that leverage contextual embedding to generate adversarial examples. So the contextual embedding captures the meaning and the content of a word, allowing more sophisticated and targeted replacing and manipulated model prediction. Okay. So our novel approach, fast gradient sign method, which is called the FGSM. Okay, so we call it the FGSM is applied to GPT-2 for generating adversarial example in the NLP. So this approach offers simplicity, efficiency, and does not have specific requirement for generating adversarial examples. The FGFM, simple and efficient method. So the FGFM is a gradient-based method that perturbs input example by taking a small step in generating gradient of loss function with respect to the input. Applying the FGSM to GPT allows for generation of adversarial example quickly with minimum computational overhead. So no specific requirement. So one advantage of using FGSM with GPT is that it does not require specific knowledge about the target model, architect, or parameters. This makes the approach widely applicable and flexible to generating adversarial example for different NLP tasks and models. So what is evaluation of various NLP tasks? So the effectiveness of SGSM applied to GPT-2 has been evaluated across a range of NLP tasks, including sentiment analysis, text classification, name entity recognition. The results demonstrate a capability of FGSM generate adversarial example to deceive the NLP model and cause the misclassification or incorrect prediction. So demonstrating the effectiveness. Okay, so through the empirical evaluation, FGMS applied to GPT-2 shown effectiveness in generating adversarial examples that can be manipulated and output of NLP models. The pros highlight a vulnerability of NLP models to adversarially attack and emphasize the need of robust. Okay. Methodology: generating an adverse example using GPT-2. So, the objective to demonstrate the effectiveness of GPT-2 is generating an adversarial example for NLP model. This involves a series of steps, including gaining access to GPT-2 API, selecting a target model, and developing an appropriate strategy. So, the GPT-2 API access. GPT-2 offers an API that allows users to interact with language models and generate text. Access to the GPT-2 API enables the generation of a diverse, contextual, relevant text, which can be used in crafting adversarial example. So target model selection. So the next step is to select a target MLP model for which the adversarial example can be generated. The target model can be sentiment analysis classifier, text generation model, or any other NLP model of interest. With the strategy of development. So once the target model is selected, the focus shifts to developing an effective strategy for generating adversarial example. This may involve applying various techniques such as sentiment replacement or gradient-based method, or maybe advanced approaches. So iterative process. So generate effective adversarial example with GPT typically involves an iterative process by experimental or refinement. Okay, so strategy may be adjusted or can be fine-tuned or to maximize the input of target models and prediction. Okay. Strategy on generating the adversarial example using GPT-2. So the strategy development. Once the target model is selected, the focus shifts to developing an effective strategy for generating an adversarial example. This may involve applying various techniques such as sentiment replacement, gradient-based model, or other advanced approaches. So here's your process. So generating an effective adversarial example for GPT typically involves an iterative process of experimentation of refinement. Strategy may need to be adjusted and fine-tuned to maximize the impact of the target model prediction. Effectiveness and quality evaluation. So in order to evaluate the effectiveness of generating the adversarial example for using GPT-2 testing was conducted on a data set of 10 text samples. The result of the testing reviewed at a remarkable high success rate of 90% generating misclassified examples. This indicates the capability of GPT-2 to manipulate the prediction of NLP model and deceive them into making incorrect classification. The generated adversarial example are assessed by the similarity to the original text using a BLEU matrix. We call it the high blue score obtained indicate the modification made by GPT-2 to originate text or are convincing and natural sounding, enhancing the stealthiness of the adversarial example. The high success rate and natural sounding modification highlight the potency of GPT-2 in generating adversarial example that can be effectively deceive NLP model. These findings underscore the need of robust defense and through evaluation of the NLP model and generating adversarial attacks. So we want to now move into the evaluation proposed. Okay, so the effectiveness of the method of generating an adversarial example are evaluated by 3 benchmark data set, the YEP, MR, and the IMDb. The data set represent different NLP tasks and provide a comprehensive evaluation of a method performance. The 3 data set used for evaluation are the YEP, MR, movie review, and the IMDb, Internet Movie database. These datasets cover a range of sentiment analysis tasks, allowing for comprehensive assessment for method effectiveness across different contexts. The result of the evaluation on the benchmark dataset are summarized in Table 1. We'll see that. And the table represents key metrics such as attack success rate, accuracy, and other relevant evaluation measures. Improved attack success rates. So the method of significantly improved attack success rate compared to the baseline method on the benchmark dataset. This demonstrates the efficiency of method in generating adversarial example and can be deceived NLP model and lead to misclassification or incorrect prediction. So the next slide, you'll see the data. So the result of the evaluation benchmark dataset is summarized in Table 1. Okay. The table represents key metrics such as attack success rate, accuracy, and other relevant evaluation measures. So again, we move on to the evaluation of proposed methods of a sentiment analysis. Okay, if you notice in here, you see the numbers on Table 2. Okay, the result of adversarial attack on sentiment analysis models. Okay, using the data set, yep, MR, IMBT, the BERT base, and the GPT model, and the other method. Okay. Over here, you see Table 3. This result of the adversarial attack on sentiment analysis model we talked about earlier. Notice the data set would be the YEP, MR, and the IMBD. Notice the BERT base and the GPT-2 and the other methods. Okay, so these are the other results of adversarial attack on sentiment analysis model. So let's talk about the limitation of the study. All right, so we want to focus only on generating the adversarial example for sentiment analysis model. We saw that earlier. It may not apply to the NLP task or models. Okay. Then we have to talk about the computational resources. This is a significant computational resource required by you for using GPT-2. Scalability approach may be limited. Okay. So the specific domains, study limit to 3 benchmark data set. Okay, we saw that 3 benchmark data set for sentimental analysis. Generability to other domains or data set may vary. Okay. Adversarial robustness. Okay, so this is effective against more sophisticated attacks, or you say defense or uncertainties. Interpretability. Okay, used to black box model like GPT-2 limits interoperability of generated adversarial attacks. Impacts or examples on underlying model may be difficult to understand. And then you have the data availability. So success of the approach depends on the availability of the large amount of high quality training data. Okay, so real world data availability may pose challenges on that. Okay. So we want to talk about the insight of the open challenges, okay? So in the effective and efficient method, we want to develop more advanced technique for generating adversarial example for using GPT-2. Explore a gradient-based approach or generate an algorithm for improved effectiveness. We also want to talk about the robustness evaluation, which is a developed method to evaluate the robustness of sentiment analysis model against GPT-generated adversarial examples. Explore new metric or combine existing matrix and adversarial example. Ethic and societal implications. Okay, so investigated ethical consideration and potential defense against malicious use of GPT-generated adversarial examples. Develop technique for detecting and mitigating the impact of such example. So what we want to talk about, what the future research and direction, where we want to go with this. So the future research and direction continue to explore the potential of large language models like GPT-2 generating the adversarial example. Conduct research or related areas such as explainability. transferability, and robust or adversary examples. Okay. Implication and future directions. Compromising ML model security and reliability. Adversary example have the potential to compromise the security and reliability of ML model by using misclassification and incorrect prediction. Better understanding of vulnerability of NLP models. Adversary attacks provide valuable insight into the vulnerability present in NLP models. Developing more robust models. The knowledge gained from adversary attacks can be leveraged to develop more robust NLP models that are resistant to such attack. The conclusion. Approach. So to utilize a GPT-2 state-of-art language model, this is what is good to use. This is our approach. Objective to generate adversary example for sentiment models, NLS models. Evaluation. Use the 3 benchmark data set used for sentiment analysis and effectiveness. Our approach successfully generates example that full sentiment analysis and models. Okay. Thank you, and this is the conclusion of my presentation. Thank you very much.